Hey, what's going on, guys? This is MJ back with another FRC programming in WPILib tutorial. So in this episode, we actually get into the fun and exciting stuff. So in this episode, you're going to be learning how to program a basic drivetrain and how you can actually control that with a joystick or an Xbox controller, for that matter, or whatever controller you would like. So without further ado, let's just get straight into it. Alright, so step one, as always, is to just create a new project. And I'm going to use template, Java, and then command robot. We're going to select our folder, which can be anything of your choosing. I'm going to name this tutorial Arcade. Actually, I'll name it Tele-op Drive tutorial. And just enter your team number. I explained why that was important in the first episode of this tutorial series. And once you're ready, just go ahead and press generate project. And I'm just gonna wait for it to build, and when it's done, we should be able to get to the interesting stuff. So as you can see, after waiting 40 seconds, it says build successful in green, which is a good sign that we're ready to get started. So here you'll see the source folder, and you'll see the Java folder, and then you'll see two folders, commands and subsystems. So for right now, the very first step is going to be all in the example subsystem.java file. So when we're thinking about a drivetrain, right, what are the physical components in the drivetrain? Because essentially what a subsystem is just the physical components of any given system, right? So like if you have a climber subsystem, that would include your climber motors. If you have a drivetrain subsystem, that would include your drivetrain motors. If you have a shooter subsystem to, shoot balls, you would have your shooter motors. And, you could have other stuff such as, other sensors like color sensors for, various different purposes. But the point is, a subsystem is just, think about it very simply as the simplest physical representation of a section of your robot, essentially. So, we're gonna want to make a drivetrain subsystem. So what we can do is we can rename this. You can right click and then press rename, and then type in drivetrain subsystem, and just press enter. And this little pop-up will show up. If you don't have this extension by Red Hat, you should probably download it because it's really helpful. And just press OK. And just so you know, that extension is located right here. It's called Language Support for Java by Red Hat. So you'll see that we've renamed our Java file to DrivetrainSubsystem.java. And we can rename this command to something such as teleoperated drive command. That's not really the best name, but I'll actually do something simple. I'll just say drive with joystick command. I think that's more simple since we're just starting out. And just press OK. So yeah, there we go. So we've just made our drivetrain subsystem and our drive with joystick command. Alright guys, so now we're actually ready to start declaring our objects in this subsystem class for our drivetrain. So you'll see that our drivetrain subsystem extends this class called subsystem base, and you'll see that the subsystem base class is just literally a base for subsystems that handles registration in the constructor and provides a more intuitive method for setting the default command. So you don't really need to understand like what that means. All it means is that any subsystem that you create will act as a subsystem, right? So like same thing with command. It extends the command base, which just means that any command, all your commands are going to do different things, but they're all commands. Okay, so just think about it like this. You could have a drive with joystick command, and then you could have a drive autonomously command. The commands do different things, but they're still both commands, right? So that's just kind of what this little extends means If you're familiar with inheritance, that'll make a lot more sense, but that is essentially the essence. So another quick example, if you have if you have one drivetrain subsystem and a subsystem for your shooter, the two subsystems will have different motor objects and different sensor objects and different, maybe behavior in this little periodic function and different methods. But at at the end of the day, they're just both subsystems, right? They have different objects. They represent different physical objects on your actual robot, but they are both subsystems. So I just wanted to clear that really quick. All right, so now we can actually get to writing the code for our drivetrain subsystem. So the very first thing we're going to want to do is, well, first of all, we can actually delete this simulation periodic because we're not going to be using simulation. So just go ahead and delete that if you have that. And now you're just left with this nice and simple drivetrain subsystem class. So what we're first going to want to do is, if you're thinking about a drivetrain, right? What actually is a drivetrain? Well, a drivetrain is literally just motors, okay? So in this tutorial series, our test chassis, it has 4 Neo motors, okay? And the Neo motors have built-in encoders into them, which is very convenient, which is why a lot of teams, and I'm assuming if you're watching this tutorial, you probably are using Neo motors as well on your drivetrain. The Neo motors are very convenient because they have encoders built into them. They're reliable and they're also pretty powerful. So I like to think of the Neo motors as kind of like the golden standard for simple drivetrains, and that's at least what we use on our team. So your first thought might be, if I'm trying to create an object for our motors, why don't I just do something like this? So the first problem is this isn't syntactically correct. There's no there's no class in WPILib called a motor. So this is essentially what we're going to be doing, right? We're going to be creating a motor called motor 1, motor 2, motor 3, motor 4. But this doesn't work because WPILib doesn't have a class called motor, okay? And the other thing is, this does make sense because a motor is literally just a physical component, okay? There's no way to interface that in your code without something called a motor controller. And with Neo motors, the ones that we're using, they're called Neo motors. They're made by this company called Rev Robotics. And Rev Robotics has made the motor controller called the CAN Spark Max, okay? And CAN Spark Maxes, these little motor controllers, are connected to the motors, and they are actually what allow us to control these motors. So the syntax for creating a motor controller object, or a CAN Spark Max in this case, what we're going to want to do is to make the CAN Spark Max object, this is the syntax you're going to want to follow. So you're going to type in CAN Spark Max, just like that, and you're going to want to name your CAN Spark Max object. So assuming you have 4 motors, you would do, you could have something like motor 1, motor, you could have a motor 2. But this honestly isn't really a good naming convention because when you're actually looking at your robot, this wouldn't really make much sense. So what I like to do is I like to do something along the lines of assigning a direction with my motor controllers. So for example, I could have the left side, and then I could do the front, right? So you would have a left and a right side, and you'd have a front and a back. So this is obviously all relative. It honestly does not matter, but it kind of just makes it easier when you're doing stuff with like autonomous path following and whatnot. So I can just name this left front motor. And what you're going to want to do is you're going to want to set it equal to, you're just going to construct a new object. So you're going to make a new CAN Spark Max object. And you're going to see that you should just be able to, you might think, well, why am I not able to, why is it giving me errors, right? I mean, I just made a Spark Max object. Well, the problem is that the CAN Spark Max class, it's not included in the WPILib classes. So you see this little folder called vendor deps where it says WPILib new commands. All of our libraries that we're going to be able to access come from this little vendor dep. Vendor dep is essentially, think about it like third-party libraries, okay? So one of our libraries that we have included is WPILib's library. Now, what's the library for the CanSpark Max, right? So luckily for you, I've already done the hard work and found it out myself. But you can go to this little web page right here. It's basically just the revlib information. It'll be linked in the description, and just type in Control F and type in JSON. That's just JSON, and you'll see this little link. Right click on it and type in copy link address. Now, what we're basically going to want to do here is install this JSON file, or kind of just put it in this little vendor deps file. Now, you might just think, right click on this folder and type in paste. Well, the problem is there's not an option, okay? Now, what we're going to want to do is we're going to want to press Control Shift P, or Command Shift P if you're on Mac, and you're going to want to type in Manage Vendor Libraries. And you can see if you press Manage Current Libraries, you'll see this little WPILib new command is showing up. Now you can click this and press OK, which would uninstall it, as you see. But we don't want to uninstall it. We actually want to install a new library that we don't have. So we can just go ahead and do that again. It's already there for me. Manage vendor libraries. And go all the way down to where it says install new libraries online. And this is where we're going to paste in that little JSON URL that we got from RevLib's website, or RevRobotics website. So just type in Control V, and you should just be able to press enter. Now you're going to see this little pop-up, and you're going to want to say yes, because after you've imported a new library in your vendor deps folder, you want to build your program so that VS Code kind of recognizes it and you're able to use the library. So just press yes, and it'll build. It actually doesn't take very long. But you'll see, it said build failed, right? Now, the reason this failed is that our syntax is incorrect. And the other problem is that it can't be resolved to a type because, once again, this little import statement right here, this is just, for extending the subsystem base. But we need an import statement to be able to access this little revlib.json file, okay? Now, if you hover over it, the convenient thing is, now that we have actually added the revlib.json file, we're able to go to quick fix and press import CanSpark Max. Now, the interesting thing now is that it automatically added this little import statement for us, and you'll see that this little error went away, right? So you might be wondering now, well, why is there still an error? And the problem is that the constructor for this object takes in two arguments. So the first argument is going to be the actual number that the like the port number that your motor controller is assigned to, which can simply be accessed using like RevRobotics CanSpark Max identification tool, which I will post. I'll see if I can find a tutorial online, but it's pretty straightforward. It's not too complicated. But basically, you would just enter a port number. So, I'm saying port number, but it's essentially like ID. CanSpark Max ID is the actual term. So let's say the ID for my left front motor is ID 1, and that's just an integer. And the other thing you're going to want to put is the type of motor this is. Okay. Now, in this case, we're going to be using a brushless motor. Okay, and we can just say brushless. Well, you'll see that this didn't actually do anything because that's not the correct syntax. The correct syntax to declare a motor type is going to be as follows. You're going to want to type in CanSpark Max, and this is where it gets interesting. You're going to want to type in low level. Now, what this means is it's interfacing with the motor type on a low level, as in hardware level. Okay, that's what low level means. And you're going to want to type in .motor type, and you'll see it kind of auto-completed for us. .motor type, and you'll see we have these little options, okay? We have brushed, brushless, and those are kind of the only two options that you can use. In this case, we're using brushless motors. If you're not sure, you can always look it up, but you're probably using brushless motors for your drivetrain. So yeah, you can always look it up, no worries. So that is essentially one CanSpark Max object done. So if I just try to build this code just to make sure we don't have any errors, we should see that it should work, hopefully. if there's no errors. Let's see, it should be building anytime soon. This is my favorite part, just waiting for it to build. So yeah, you'll see build successful. So excellent. Now that the build is actually successful, we can go ahead and you shouldn't copy and paste, but since I'm lazy, I'll just Control C. So basically, we have 4 different motor controllers, okay, and we want to title these different things, okay. So for example, we have left front motor, now we have left back motor, and then we have the right front motor, and then we also have the right back motor. Okay, now this might look all in well, no errors, but notice how the CanSparkMax ID is actually the same for all of them, which you don't want. So if you hover over here, you'll see that the constructor for this takes in a device ID and a motor type. Okay, so you can't actually have the same device ID number for different motor controllers, okay? Because essentially what you're saying then is, regardless of the name of the object, you're essentially just controlling the same motor, okay? So we'll name this 1, 2, 3, and 4, okay? And in my case, I've already looked up the in the CanSparkMax ID identification tool, I've already just set them to 1, 2, and 3, and 4 for simple purposes. Once again, I will try to link like a tutorial in like down below in the description, or like a web page to help you out with identifying what ID your CanSparkMaxes are set to. But it's very straightforward, honestly. You can just download the software and probably figure it out yourself. So regardless, you'll see that we actually have 4 different CanSparkMax motor controller objects. Okay. And you'll see that they're assigned to different device IDs. So now if we try to build our robot code, you'll see that it should build successfully, okay? Okay, so now really quickly, I want to explain the importance of the Constants.java file. So you'll see these numbers are pretty much constant, right? They're never really going to be changing. So that's essentially what the Constants.java file is for, right? Because this file is essentially just for variables and primitive data types that are essentially used throughout the code that we don't really want to have to go through the headache of constantly changing them in each individual class. So we can literally, in this constants file, we can assign different integer variables to these variables, and we can just call them, we can just access them through this constants file, and that would apply globally. So what we want to do is, within this constants.java class, we want to create a different class, for organization's sake, to store all of our drive constants or drivetrain constants variables. So it's like not a good practice to actually like have classes within classes, but for this purpose it makes perfect sense, because that is essentially what we want to do, right? Because we just want to have a class within, we just want to have a bunch of different classes within the constants class to hold different constants for different subsystems or whatnot, right? So we're gonna have a public static final class called drivetrainConstants, and basically what we're gonna want to do, and the reason this is static and final is that we want to be able to access it directly without having to do any weird like getters and setters, and it gets really weird if you don't have it in static, because we're just trying to access these variables directly. We're not necessarily going to be changing them here, but we're literally just going to be accessing them, which is why we have static. Okay, and we want to make all of the variables static as well, and they're also going to be final, because we are not really going to be changing them outside of this class. So what I can do now is I can actually declare these different variables. So I can type in public static final int, and I can just do left front can ID equals, and I can just set that equal to 1 public, and I'm not going to bore you by typing this all out. I'm just going to copy and paste this. So we have left back right front, and we have right back. And essentially now we have left front, left back, right front, and right back. Okay, so you'll see we have left front, left back, right back, which is exactly the same thing as what we have here. So we can just assign these 1, 2, 3, 4. Now we can just assign these simply by doing the following. We can literally now, what we're gonna actually have to do is we're gonna have to import the constants file. You'll see. But if we can just do constant or cons, I don't know, ignore that. That wasn't supposed to happen. We have constants dot drivetrain constants dot, you see, dot left back can ID, and we didn't actually need to import it because we're calling it directly from the constants file, and it actually I think it actually already imported it for us. Let me make sure. Yeah, it did. Okay, sweet. So just in case you're wondering, you know, what just happened, it says it can't be resolved to a variable, so you go to quick fix and you just import constants. Okay. So dot left front can ID, and then we can literally just do this for everything else. Okay. So dot left front. Oh, I'm tripping. Hold up. Left front. Sorry about that, guys. Left front. Left back. Constant. Oh my god. Constants dot drivetrain constants dot right front, and last but not least, constants dot drivetrain constants dot right back motor. Okay, so sorry if that was like really long and boring and mundane, but basically you can see that this is essentially the proper way to do things. And the reason I'm enforcing that right now is that there are kind of habits that will develop over time. So it's really important that, you know, you kind of just get in the habit of declaring your constants in this little file. So yeah, that was just basically that's basically how you declare, the proper way to declare your motor controller objects. And now we can actually get into declaring the other fun stuff. So the next thing that we're going to want to declare is our encoders. So remember how I mentioned that these Neo motors have built-in encoders? Well, how are we actually going to access these encoders, right? So the syntax to do that is going to be the following. You're going to use the relative encoder class that's provided by Rev Robotics. And the nice thing is it'll automatically import things for me with VS Code. If it doesn't do that, you can kind of just like hover over it. I know sometimes it doesn't do that. Hold up. Encoder. If it doesn't do that, you can kind of just hover over it, and then you can just go to quick fix, and there will be an option to import it, kind of like how I did with the constants class. So you can just do relative encoder, and then you can name this encoder, right? So you can name this left encoder, and this is just equal to the left. You can choose which motor you want this encoder attached to. So essentially we have 4 motors and 4 encoders, but for our purposes, we really only want to use 2 encoders, one on the left side and one on the right side. So I'll just set these equal to the front motor dot, and now what you're going to want to do, pay attention, what you're going to want to do is use this little method, dot get encoder. Now how simple is that, right? This little get encoder method, you can see that all it is doing is returning a relative encoder, which is why this works, right? So now what we can do is we can create a new relative encoder, and we can call this right encoder, and this can just be equal to the right front motor, and we can just do dot get encoder. Excellent. So just to make sure everything's working, we can just build our robot code once more. And hopefully this should work. Build successful. Sweet. So we know that we're ready to move forward. Okay. So what we have to do next is we have 4 motor controllers and we have 2 encoders, one for the right front motor and one for the left front motor. Okay, so now what we want to do is we want to group our motors. Okay, because on one side we have 2 left motors and on the right side, which is the other side, we have 2 right motors. Okay, now we want to create groups of the left motors and groups of the right motors. So the way to do this is you call the use the motor controller group class, which is very convenient. And as you can see, it automatically imported it for me while I press enter. Once again, if it doesn't show up, you can just hover over it, press quick fix, and there should be an option to import it. Okay, so motor controller group, and then we can just do left controller group equals. And now what you want to do is you're gonna want to say it is equal to a new motor controller group, and you'll see that what you can do now is call your actual can spark maxes. Okay, so you're gonna do left front. It doesn't actually matter the order you put this in, it's just as long as they're in there. Left back motor. Okay, and that is one motor controller group. So let's just do the same thing. Motor controller group, right controller group equals new motor controller group, right front motor, and then we can just do right back motor. Excellent. So now, so now essentially what we've done is we've created 4 motors, or motor controllers. We've created 2 objects for the encoders, and we've created 2 groups, one for the left group and one for the right group. So excellent. Now what we can actually start getting into is the fun stuff. Okay guys, so before we actually get to like the fun stuff, I should say there's a couple more objects that we have to create. So we're going to use the differential drive class. So this is essentially just a class for tank drive drivetrains. So tank drive is essentially our drivetrain, right? Because it's not a swerve drivetrain where it can move holomonically in 360 degrees of freedom. This is essentially kind of like the ideal drivetrain. Forward, backwards, turning. Simple, slow. It's slower than swerve, not as much maneuverability, but the differential drive class is what we're gonna call for tank drives, which is or differential drive is what it's called, but they're the same thing. Okay, so what we're gonna want to do is we have a differential drive class, and we're gonna want to name this differential drive. Okay, and this is gonna equal to a new differential drive, and you're gonna want to put in your groups, right? Remember the groups that we had? So essentially, this is just combining everything, right? This is kind of just like the end all be all. It's basically combining your 2 groups, and within your groups you have your motors. So you have a total of 4 motors, 2 groups, and 1 sort of hub, okay, which is the differential drive. It's just kind of like your drivetrain almost. This is essentially just representing your drivetrain with 2 groups and 4 motors. Okay, so left motor controller group and right controller group. Excellent. And once again, we have no error. And once again, we have no errors, which is always a good sign. So that is literally everything in terms of instance. This is all of our objects, our instance objects that we would need to create in our drivetrain subsystem class. So now we can actually get into the fun stuff. Okay, so when the constructor is called in our drivetrain subsystem, okay, what do we want to do? Well, the first thing we want to do is let's just make sure everything is zeroed out. Okay, like when I turn the robot on and I call this method, I want it such that whenever I'm using the subsystem, whenever I'm creating an instance of the subsystem, I want to make sure that everything is just zeroed out. Okay, so what I'm gonna do is I'm going to make sure that the encoders are set to 0. So I can do left encoder dot set position to 0. Okay, so this means that every time whenever I have an instance of this and I deploy my code and it's called, everything will just be 0. Okay, so I can also do right encoder dot set position, and I can just do 0. So that's zeroing out the positions. Okay. Now the next thing we want to do is we want to assign leaders and followers. Okay. So essentially we want to tell one motor to follow another, right? So on the left side, we want one of the left motors to follow the other left motor. On the right side, we want the right motor to follow the other right motor. Okay. So we'll just make the back motors follow the front motors because that kind of makes the most sense. Because for my encoders, I'm using the front motors on each side as my kind of leaders, if you will. So what we're gonna want to do here is we can literally just call the follower. Okay, left back motor dot follow, and you'll see has a leader, and you can do dot follow, and then all you got to do is type in the follower, left front motor. Okay, same thing, right back dot follow, right front. Sweet. So we're zeroing them out, then we're telling them to follow their leaders. Okay. Now one more thing you can kind of just do at the top, just as a safety mechanism. It's honestly kind of useless, but just a good thing to do in practice, right? Is just to restore everything to factory defaults. Okay. So I like to do this just to make sure that everything is just kind of reset, everything's fresh, right? Just a good idea so that nothing else from a previous test was interfering. Okay, so just do restore factory defaults. Quite simple. Okay, I would say this is optional, but I would just recommend doing it because it doesn't hurt, and it just kind of gives you the benefit of the doubt, kind of removes any paranoia you might have. But yeah, basically not required but recommended. Okay, so just zeroing everything out here, resetting everything, making everything's good. Then after that, we want them to follow each other. After that, there's really nothing else we wanna do. Okay, basically this is really the simplest form of what we're gonna have in terms of just getting a driving with a joystick. Okay, so well, what do we want to do next, right? You might be wondering, how are we actually going to get into driving this thing? We have our drivetrain subsystem here. Okay, but how do we actually get this to do something? And that is where things get fun. Okay, guys, so now what we can do is we can actually mess with this little command because our subsystem is essentially done. So sweet. I'll just close this out. So what's the very first thing we want to do? Okay, you'll see that we have this drivetrain subsystem declared already. I'll just rename this drivetrain subsystem. And the reason we have this in our this instance in our command is that we want this command to act upon the drivetrain subsystem. And the way we're gonna do that is we're basically gonna say that this drive with joystick command is gonna take in a subsystem called DrivetrainSubsystem. Okay, and I can just rename this drivetrain subsystem as well. And what I'll do is I can use the this keyword, and I can say this, which is just referring to the class the class version of drivetrain subsystem. This drivetrain subsystem is equal to drivetrain subsystem. And all you got to do then is add requirements. This little add requirements will declare the subsystem dependencies. So it'll make sure everything is from the drivetrain subsystem is actually going to be interacting with our command. So nice. So this basically means now that we have a drivetrain subsystem object, okay, and we're taking in the constructor, we're gonna pass in a drivetrain subsystem, okay, and we're just gonna assign them equal to each other, and then we're just gonna add the drivetrain subsystem, okay. So what we want to do next is in the initialize function we can have something simple such as sysout, I don't know, let's just say starting joystick command, joystick drive command. Okay, and this will just basically mean that when we call this command, the very first thing that will happen is in our terminal or our console, it'll print this little string out, okay? So that we know that we're actually reaching this part of our code. Now, this is the execute. This is where things actually get interesting. This is where we actually get into basically making this command do stuff. This is essentially where everything happens, right? This is where all this boring stuff actually comes to life, because the execute method is essentially stuff that is executed. Okay, so what we're gonna want to do is we're gonna want a forward speed and a turning speed. Okay, so what we're gonna say is we're gonna have a double, and we're gonna say forward speed for going forwards and backwards is going to be equal to, now what would this be equal to, right? Because we want to use a joystick, so we could say something like, let's just think about this. We could do something like joystick dot get forward speed, and then we could do something like double turning speed equals joystick dot get turning speed. So this makes sense in theory, but we don't have any joystick object, and there's no such thing as just this little method just built into the joystick. So what we're actually going to want to do is we're going to want to create an instance of our joystick somewhere. Now, where would we create that, right? Well, it wouldn't really make much sense to create this over here, like within our command. We could do that, but that's not a very good idea, because we want our joystick to be able to control other commands as well. We don't want it just restricted to this command. So what we're going to end up doing, okay, we are going to head over to the robot container, okay? And over here, what we can do is we can actually make a joystick. And the reason we're doing this in the robot container is because this is, remember, where we declare our robot, okay? The robot container is where we have our commands and subsystems and joysticks and Xbox controllers, because in this little method, configure button binding, it's essentially gonna use the joystick object we have here and bind commands such as this command, or our DriveWithJoystick command, to a certain button. So what we're actually going to want to do here is we're going to want to create a joystick object, okay? So this is going to be simply called public static joystick. We can just call it joystick equals new joystick. And it takes in a port, which is, if you hover over this, it's just the port index on the driver station that the joystick is plugged into. So that's pretty straightforward. So for me, it's usually 0, but it can always just change. You can always check. So yeah, the reason this is static is because we're going to access it directly here. So we actually have a joystick object now. So all we got to do now is I can simply just erase this. I can just do RobotContainer dot, and you'll see this joystick object appears. That joystick dot, and now what do I want to do? The forward speed. You see all these methods, and you're like, well, what do I put in? So, luckily for you, there's this. Okay, this is a flight controller that I'm using, and that this is pretty conventional, regardless of the flight controller you're using. You obviously might have to check if it's different, but the Logitech flight controllers are usually, the x-axis is axis 1, and that's forwards and backwards. So that's just forwards and backwards speed. The y-axis is left and right, which is axis 2. That's left and right. And the twist is actually twisting this little joystick, and that's axis 3. So for me, I like to use the x-axis and the twist axis because that's most intuitive, forward, backwards, and actually twisting it to turn. But you could always also use x and y. Doesn't really matter. So in this case, what we're going to want to do is we're going to do dot get. And you'll see this little dot get x. And that's exactly what we need, because that is just getting the forward speed. Because remember, x is forwards and backwards. And then for the turning speed, we can just do RobotContainer.joystick.get. Now you could do .getY or .getZ. Either one works. It's just personal preference. Would you rather tilt the entire joystick handle to the left to turn, or would you rather just twist it? I like to twist it. I think it's easier. And bam, that is pretty much, you'll see, that is essentially pretty much the end of, you know, the command for just driving. But yeah, so what you'll see now is that what we can do is this command is done and our drivetrain subsystem is done. So what do we want to do next? Okay, so what we're going to want to do is in our robot container, this is, you know, where all of the interesting stuff happens. Okay, we're going to go down here in the constructor for our robot container. Okay, and below where it says configure button bindings, all we got to do is, well, we got to call our drivetrain subsystem. So before we do anything, I'm just going to rename this to drivetrain subsystem, and I'm just going to name this to drive with joystick command, and I'm just going to name this to drivetrain subsystem. Okay, sweet. So, really quickly now, what we're going to want to do is we're going to want to call our drivetrain subsystem. Drivetrain subsystem. Okay, and then we're going to do dot, and then we're going to do set default command. Okay, now what set default command is, right? If you hover over it, you can see that the default command will automatically be scheduled when no other commands are scheduled that require the subsystem. Okay, so what this means is that since we don't have any other commands that are scheduled that require this subsystem, remember over here we added this requirement. So this command is requiring this subsystem, which is why we use add requirements, because it's depending on the drivetrain subsystem. Okay, so you'll see here that no other commands are scheduled that require the subsystem, right? So this is the only one that does. So this will essentially, what we can do is we can just do a new. We can just call the command now, because this method this method takes in a command. Okay, so we can just do new drive with joystick command. I'm actually creating a new command here, which I don't want to do. I just want to copy the command that I already made and just put it in here, because there's really no point in creating new commands, right? Because this is one command that I'm using. Okay, so you know, this is why all your subsystems and commands are defined here, because you have one drivetrain subsystem, you have one drive with joystick command, and you just kind of want to use them the same exact instance of this throughout. So here you'll see there's an error. Okay, so all you got to do here is, for right now, since we're actually not doing anything in the autonomous period, all we can just do is we can just return that command, drive with joystick command. And what this will do now is, regardless, autonomous, it'll just run this command pretty much. Oh yeah, and a quick little thing, we're going to want to make sure our inversions are set correctly. So what this basically means is that you want to invert your motor controller groups, because, you know, just out of the box, one might be going one way and the other might be going another way. So the easy way to do this is to just type in your motor controller groups and do .set inverted. And you're going to want to make one of them to true. In my case, the right side will be inverted, and the left side will not be inverted. Because, you know, essentially, you want one to be inverted and the other not to be. Okay, and if this doesn't work, you know, when you're actually deploying your code and testing it out, it'll be a good idea to kind of just play around with the inversion and see what works in the logical direction. But yeah, so you'll have them inverted, and basically play around with it, see which inversion works for you, and yeah, everything should work as expected. So yeah, thank you. Now all you gotta do is you just gotta deploy your code. So make sure that you're tethered into your RoboRio via printer cable, okay? And just press Control-Shift-P, and you should just be able to press deploy code. So this will take a minute or two depending on how fast your CPU is. But yeah, I'll be back. So yeah, guys, as you guys just saw in the video, you guys now should have a fully working um, robot that should be able to be you can drive it with your joystick. So yeah, thank you guys for watching and stay tuned for the next episode.